Good afternoon to all. I am RAJKUMAR M.E. ECE. Today we discuss about the topic of IC fabrication. IC mean integrated circuits. What is IC? An integrated circuits accommodating billions of electronic components in a single chip, as small as an fingernail. That's microchip IC. IC functioning counter, memory, microprocessor and so on electronic circuits. And IC categorized, there are two, one linear, another one discrete. Past years we use the vacuum tubes like this. So 20th century we use the vacuum tube. The vacuum tube is larger and expensive and power hungry device and then unreliable one. This is 1940s computers is introduced. That computer size is double decker bus size, and then need one mini electricity plant. Why the integrated circuits we are used? First of all, reduce the size of transistor. Our human hair size is 80 micrometer, but a single transistor size is 0.01 micrometer dia. So the processing speed is higher and good performance to the IC. Reduce the power consumption, lower manufacturing cost also. The first invention IC 1958 was put forth by Jack Kilby at Texas Instruments. First planar IC introduced in 1960, and 1967 the world first handhold electronics calculators introduced in 1967. 1971 Intel Corporation introduced in microprocessor 4004. Evolution of IC 1960 first introduced in small scale integration, the SSI. It's contained only 100 transistor. That IC used to logic gates. And MSI 1966 introduced. It contained transistor count is 500. This IC used to logic function and counters. LSI, the mid of 1970s introduced in LSI. This IC is contained 10,000 transistor. The first microprocessor introduced in this types of integration. Next, VLSI. VLSI introduced in last of 1970 or 1971. That integrations is contained more than 10,000 transistor. So these types of integrations using 64-bit microprocessor and then cache memory also. So 1984 introduced in ULSI. This more, it's contained the transistor count is 1 million transistors. Moore's law. Moore's law is the abbreviation that one number of transistor on a microchip doubles approximately every 2 years. X-axis is denoted as years, and then y-axis is denoted as utilization of transistor contain the transistor. Okay. This Moore's law, the years is increases, the transistor contained transistor strength also increases. IC technologies. What are the IC technologies used? up to this day. First one, bipolar technology, that's TTL, ECL. TTL means transistor logic, ECL emitter coupled logic. This is first use that technology. Next we prepone to the MOS, metal oxide semiconductor, NMOS, PMOS and CMOS. CMOS, complementary metal oxide semiconductor. The combine of bipolar and CMOS technology is a bi-CMOS technology. Bi-CMOS technology has gallium arsenide and silicon germanium also. So, just silicon germanium used for RF technology. RF is radio frequency technology, and gallium arsenide is used to high speed technology. So, basic steps for IC fabrication. We have 9 steps is there. Okay. First one, wafer production. Second one, epitaxial growth. Third one, masking. Fourth one, etching. Fifth one, doping. Sixth one, atomic diffusion. Seventh one, ion implementation. Eighth one, metallization. And ninth one, assembly and packing. First step, wafer production. So, it is base, the wafer is base or substrate to the entire chip. Okay. First purified polycrystalline silicon is created from a sand. First the silicons collect from a sand. Okay. Then that silicon to be heated, and then it is converted to molten liquid. That liquid slowly cooled from, and then crystal ignite. Ignite means shape size is this shape, ignite size. Okay. So, then that ignite to slicing, Okay. So, after slicing the wafer, that wafer some damages or some scrap is occurred. So, then that wafer to polished. Next, epitaxial growth. Epitaxial growth means, so wafer, that's substrate. So, that's uniform layer of silicon dioxide formed on the wafer surface. That step is called epitaxial growth. Next step, masking. So, photoresist or light sensitive film applied to the wafer, that's wafer, that layer is applied or mask is applied. That mask is called photoresist or light sensitive film is applied to the wafer, on the wafer. Okay. So, exposed to ultraviolet light through the mask, cutting waste positions or cutting or slotted to the mid of the deposition position. Okay. Next, edging. Selectively removing unwanted material. So, after completing the masking, next step to the edging, unwanted wasted to the removing, that's oxide film also removing. So, then that photoresist to protect the product by this edging mask. Next, doping. So, normally silicon as a atom, that atom around the 4 electrons is a pure silicon, around the 4 electrons is rounded as a pure silicon. Maybe impurities added like boron, aluminum, gallium. These impurities atom contain around a 3 electrons only. So, then antimony, arsenic, phosphorus, there are that atom around to the 5 electrons compared to silicon more than 1, this is silicon lesser than 1. So, this is impurities, this p type impurity, this also, these all are n type impurities. Next, diffusion, atomic diffusion. Diffusion means a substrate is there, okay. Diffuse the heavily doped N well or P well substrate insert to the IC, okay. So, diffusion is defined as the movement of impurities atoms in semiconductor material at a high temperature. The temperature level 1500 to 2200 Celsius Fahrenheit. It is a inert gas like as a nitrogen or argon inert gas pass through the entire IC, okay. So, then deposit the N well fully heavily doped that N well or P well full insert to the wafer, okay. They look like, though this is heavily doped diffusion stage, N well or P well process. Next, ion implementation. Ion implementation is low temperature process by which ions of one element are accelerated into the solid target. This is metal finishing area, okay. So, this connecting together silicon and then some substrates also. That is metallization. Metallization, it is used to create contact with the silicon and to make interconnection on a chip. A thin layer of aluminum is deposited over the whole wafer. So, that's aluminum is selected because it is a good conductor. Aluminum is a good conductor. That conductor is metallization. That's gate, source, drain, and then base. Okay. So, this is a mass transistor metallizations. This is so finally, each of the wafer contain 100 of chips. That's wafer size is this size, wafer size is this size, 100 of chips inbuilt in a single wafer. Okay, we cut that ICs say rectangular shape or square shape, so and so. So there's diamonds or the cut the wafer into the chip size. Then we use the chip that is failed in the electrical test are discard. Is good condition that IC to the packed. So these steps: first raw material, next wafering, polishing, and then deposition, and then photoresist, then ion implementation, wafer production, chip cutting, and then finally packing and assembling of the chips.
Humble sand.
This is sand.
This is what the building blocks of the future are made of. But making them is a long process comprising a great many steps. First, the silicon dioxide in the sand has to be converted into pure silicon. After that, it is cut into wafer-thin discs. In Dresden, these raw wafers are 300 millimeters in diameter and less than a millimeter thick. In our clean room, up to 35,000 chips are then made from each of these discs. In numerous process stages, the wafers are given their characteristic surface structure. After coating
melted liquid.
Layer,
this is melted liquid.
The wafer surface is exposed, developed, and etched. This results in the desired conductor
edging,
structure.
masking and edging process.
Are hundreds of times finer than a human hair. Dopants are then implanted in the material to increase the electrical connectivity of parts of the semiconductor. In subsequent phases, this and other process steps are repeated until the entire layout of the chip has been deposited on the wafer. This involves heating the wafer to more than 1100 degrees Celsius. In some cases, up to 27 times. Up to 200 measurements are done, and up to 26 exposures. All in all, this can mean as many as 700 processing steps and 14 weeks processing time. Once this is completed, the microchip is assembled from as many as 30 such layers, like a mini skyscraper. Each layer has its own function. Interconnecting them makes the microchip highly complex. Semiconductor chips, the building blocks of our future.
Thank you.